In this lesson, we will discuss about linear equations in one variable. These are our learning targets. At the end of this lesson, you should be able to differentiate between algebraic expressions and equations, illustrate linear equation in one variable, solve linear equation in one variable by algebraic methods, and solve problems involving equations in one variable. What is the difference between expressions and equations? Let's take a look at the examples. For expressions, we have 5x plus 8, followed by 2x plus 3y plus 7. Then we have 8 plus 5, and 4 times the quantity x plus 6. For equations, we have 5x plus 8 equals 15, 2x plus 3y plus 7 equals 10, 8 plus 5 equals 12x, and we have 4 times quantity x plus 6 equals 2. An expression is a number, a variable, or a combination of numbers and variables and operation symbols. An equation is made up of two expressions connected by an equal sign. Let's talk about the properties of equality. These properties will be used in solving linear equations. For any real numbers a, b, and c, the reflexive property states that a is equal to a, or it simply means that any real number is equal to itself. Next, we have the symmetric property, which states that if a equals b, then b equals a. The symmetric property allows us to switch the left and right side of the equation. Number 3, transitive property of equality. If a is equal to b and b is equal to c, then a is equal to c. In other words, if there are three numbers and if the first and second number are equal and the second and third number are also equal, it follows that the first and third number are equal. Number 4, addition property of equality, which states that if a equals b, then a plus c is equal to b plus c, which means that if the same number is added to both sides of an equation, both sides remain equal in value. The same principle is also applied on subtraction property of equality. If a is equal to b, then a minus c equals b minus c. If the same number is subtracted to both sides of an equation, both sides remain equal in value. Number 6, the multiplication property of equality. If a equals b, then ac equals bc. If both sides of an equation are multiplied by the same number, the results on each side are equal in value. The same principle is applied on division property of equality. If a equals b, then a over c equals b over c. If both sides of an equation are divided by the same number, the result on each side are equal in value. Linear equations in one variable are open sentences. They are neither true nor false. The values of the variable that result in a true statement are called solutions, or roots of the equation. To solve an equation means to find all the solutions of the equation. Example, determine if the given values of x are solutions to the equation. So we have here the equation 3x minus 5 equals 10. To determine if the values of x are solution to the equation, we have to substitute it in the equation. So for x is equal to 1, this is 3 times 1 minus 5 equals 10. 3 times 1 is 3 minus 5 is negative 2, and negative 2 is not equal to 10. So x equals 1 is not a solution to the equation. How about for x is equal to 2? For x equals 2, we have 3 times 2 minus 5 equals 10. 3 times 2 is 6 minus 5 is 1, which is not also equal to 10. So again, 2 is not a solution to the equation. And for x is equal to 5, we have 3 times 5 minus 5 equals 10. And 3 times 5 is 15 minus 5 is 10, which is equal to 10. So x equals 5 is a solution to the given equation. Let us now have some examples in solving linear equations. When you say solve linear equation, means to find the solution of that equation. So for example, we have here x minus 5 is equal to 12. In this case, we will use the addition property of equality to eliminate negative 5 or minus 5 in the left side of the equation. So we have x minus 5 is equal to 12. Then, to eliminate minus 5, we have to add plus 5 here and plus 5 also in the other side. Why plus 5? Because negative 5 plus 5 is 0. So we have now an equation which is x, negative 5 plus 5 is 0, is equal to 17. So x equal to 17 is the solution to the equation x minus 5 equals 12. Next example. Let's say we have n plus 15 is equal to 8. Okay, so in this case, we will use the subtraction property of equality. So we have n plus 15, and then is equal to 8. And then to eliminate 15 in the left side, we have to subtract 15 on both sides of the equation. So n plus 15 minus 15 is equal to n. And 8 minus 15 is negative 7. So n is equal to negative 7 is the solution to the equation n plus 15 is equal to 8. We can also check our answers. So to check our answer, we will have to substitute the solution in the equation. So we have negative 7 plus 15 is equal to 8. Negative 7 plus 15 is 8, which is equal to the other side of the equation. 8 is equal to 8. Notice that when we use addition property and subtraction property of equality, it is the same as moving the number to the other side of the equation and change its sign. So, for example, in x minus 5 is equal to 12. If we will move that to the other side of the equation and change its sign, that's the same as x is equal to 12 plus 5, which is equal to 17. Okay? And the same with the other equation. We have n plus 15 is equal to 8. And if we will move that to the other side of the equation and change its sign, that's n is equal to 8 minus 15, and n is equal to negative 7. So we will try to use that in the next example. Number 3, we have 2x plus 5 is equal to x plus 1. Okay, so in this case, I will arrange the members of the equation such that all the terms with variable will stay on one side and the constant will stay on the other side. So what I'm going to do here is to transpose x to the left side and transpose also 5 to the right side. So this is now equal to 2x, and then minus x. When you transpose, you have to change its sign. Notice that when we use addition property and subtraction property of equality, it is the same as moving the number to the other side of the equation and change its sign. So, for example, in x minus 5 is equal to 12. If we will move that to the other side of the equation and change its sign, that's the same as x is equal to 12 plus 5, which is equal to 17. Okay? And the same with the other equation. We have n plus 15 is equal to 8. And if we will move that to the other side of the equation and change its sign, that's n is equal to 8 minus 15, and n is equal to negative 7. So we will try to use that in the next example. Okay, next example. Let's say we have 2x plus 5 is equal to x plus 1. So what I'm going to do here is to arrange the terms of the equation such that the terms with variables will stay on one side of the equation while the constants will stay on the other side. So the first thing that I'm going to do is to transpose x to the left side. Remember that when you transpose or move a term of an equation, you have to change its sign. So this becomes 2x minus x equals. Then next is we will transpose 5 to the other side. So we have now I'm sorry. We have now 1, then minus 5, then combine similar terms. So this is minus 5 because from positive, when you transpose that, change it to negative. So we have 2x minus x is equal to x, and 1 minus 5 is negative 4. So x is equal to negative 4. Another similar example. Okay, we have here 5b minus 6 is equal to 2b plus 9. Okay, so the first thing that we need to do here is to transpose 2b to the left side. So we have 5b, then this is positive, so this becomes minus 2b, and then transpose negative 6 to the other side. So that becomes 9 plus 6. Then 5b minus 2b is 3b, and 9 plus 6 is 15. Okay, so we are only solving for b. So there should be, or the coefficient of b should be 1 and not 3. So what we're going to do here now is to use the division property of equality. Meaning, we have to divide both sides of the equation by 3. Why 3? Because 3 divided by 3 is 1. Okay, so divide this also by 3. Okay, so what is now the result? 3b divided by 3 is b, and 15 divided by 3 is 5. So the solution is equal to 5. Next example, we have here 2/3 x is equal to 6. Okay, so we have to get rid of the fraction by multiplying the least common denominator. Multiply both sides of the equation by the least common denominator. So in this case, we have the LCD of 3. So we have 2 over 3 x equal to 6, and then multiply both sides by 3. Okay, so multiply this also by 3. So the result is 3 times 2/3 x is 2x, because that 3 divided by 3 is 1, and 6 times 3 is 18. Okay, and by the way, what we did here in the previous step is the multiplication property of equality. Now we have 2x equal to 8. What's next? So we have now to divide both sides of the equation, or we use the distributive or the division property of equality, and divide both sides by 2. Okay, so 2 divided by 2, or 2x divided by 2 is 1x, or simply x, and 80 divided by 2 is 9. Okay, another example. Number 6, we have here 2 times the quantity, or negative 2 times the quantity x minus 3 is equal to 7 minus the quantity x plus, okay, so x plus 2. So before we will solve the equation, we need to simplify both sides of the equation by the use of the distributive property of multiplication. So we will multiply first negative 2 by x minus 3, so that is negative 2x, and then negative 2 times negative 3 is positive 6, or that's plus 6, is equal to 7. Uh, the grouping symbol here is preceded by negative sign. So when we remove the grouping symbol, we have to change also the sign of the included terms. So this is minus x, and then minus 2. After that, combine similar terms. We have now negative 2x plus 6 is equal to 7 minus 2 is 5. Okay, that's 5 minus x. Next, the next thing that we have to do is to transpose negative x to the left side. So that's negative 2x plus x is equal to, transpose also 6 to the other side. We have now 5 minus 6. Okay, combine similar terms. Negative 2x plus x is negative x, and then 5 minus 6 is equal to negative 1. Now, notice that the coefficient of x is negative 1. So to make it positive, we have to multiply both equation by negative 1, or divide both sides of the equation by negative 1. And because negative x divided by negative 1 is positive x, and x is equal to negative 1 divided by negative 1 is positive 1. So the solution to the equation is equal to 1. Okay, let's have another example, and this time the equation contains fractions. Let's say we have here x over 2 minus 3 is equal to 3 over 4x minus 1. Now, to simplify the equation, we have to multiply again both sides of the equation by the least common denominator. And in this case, the least common denominator is 4. Okay, so we have x minus 2, then minus 3 equals 3 over 4x, then minus 1. And then multiply both sides of the equation by 4, or the least common denominator. So from here, 4 times x divided over 2 is 2x, because 4 divided by 2 is 2. And then 4 times negative 3 is negative 12. And then 4 times 3/4 x is equal to 3x. And then 4 times negative 1 is negative 4. So we have 2x minus 12 equals 3x minus 4. Next, we will now move 3x to the left side. So we have 2x, then minus 3x is equal to negative 4. And then move negative 12 to the right side, that's plus 12. And then combine similar terms. 2x minus 3x is negative x, and negative 4 plus 12 is 8. Again, the coefficient of x is negative, so we have to divide both sides by negative 1. So from here, value of x is equal to negative 8. Let's check the solution in this example. Originally, our equation is x over 2 minus 3 is equal to 3 over 4x minus 1. And our solution is negative 8. So we have to substitute that in the equation. So this is negative 8 over 2 minus 3 equals 3 over 4 times negative 8 minus 1. Negative 8 divided by negative 2 is negative 4. Then minus 3 equals 3/4 times negative 8 is negative 6. Then minus 1. Negative 8 divided by 4 is negative 2. And negative 2 times 3 is negative 6. So negative 4 minus 3 is negative 7. And negative 6 minus 1 is also negative 7. So the solution of this equation is negative 8. Let us now proceed to the next part of this lesson, which is on solving problems using linear equations. And we have the following steps. Number 1, understand the problem. A, read the problem carefully. B, identify what is given and what is being asked. C, represent one unknown number by a letter, then try to see how an expression or any other unknown variable can be represented in terms of that same letter. Number 2, write the equation. Translate the phrases into algebraic expressions. And use the conditions in the problem to write the equation. Number 3, solve the equation and state the answer. And number 4, check the solution. Be sure to answer the question in the word problem and check that your answer satisfies the conditions stated in the problem. Let's start with number problems. The sum of two numbers is 60. The larger number is 4 times the smaller number. Find the smaller number. So the first thing that we need to do here is, of course, we have to read and understand the problem and identify what is being asked. In this problem, we are going to find the value of the smaller number and represent one unknown number by a variable and relate it to the other unknown number. So step 1, we let n be the smaller number. And also, it states here that the larger number is 4 times the smaller number. So that is 4n, that's the larger number. Okay, so n is the smaller number while 4n is the larger number. Step 2, we are now ready to write the equation. Another statement in the problem is that the sum of two numbers is 60. So we have n plus 4n is equal to 60. So this is our working equation. N plus 4n equals 60. And we are now ready to solve the problem. Okay, so we have the equation n plus 4n is equal to 60. Then combining similar terms, n plus 4n is 5n and then equals 60. And we are solving for the value of n here. So applying the division property of equality, we divide both sides of the equation by 5. And 5n divided by 5 is 1n, or we simply write n. And 60 divided by 5 is 12. This is now the smaller number. Okay, step 4 is to check the answer. Be sure to answer the question in the word problem and check that your answer satisfies the conditions stated in the problem. Okay, so step 4 is we are going to check. Our equation is n plus 4n is equal to 60 and the value of n is 12. So this is 12 plus 4 times 12 equals 60. So this is 12. Then plus 4 times 12 is 48. Is that equal to 60? 12 plus 48 is equal to 60. So 60 is equal to 60. So meaning we have the solution of the equation which is equal to 12. Next example. 4 times a number increased by 17 is 9 less than 6 times the number. Find the number. Okay, step 1 is to represent the unknown number by a variable. So we let n be the unknown number. And step 2 is to write the equation. We have to translate the phrases into algebraic expression and then write the equation. So one phrase here states that 4 times a number increased by 17. So that's 4 times the unknown number increased by is plus. So that's plus 17 is 9 less than 6 times the number. So that is 6n minus 9. So we have the equation 4n plus 17 is equal to 6n minus 9. Step 3 is to solve the equation. So our equation is 4n plus 17 is equal to 6n minus 9. So the first thing that we're going to do here is we will just arrange the terms of the equation such that the terms with variables will stay on one side of the equation and the constants will stay on the other side. So I will move 6n to the left side. So this becomes 4n and then minus 6n. Okay, so when you move or transpose a term, you have to change the sign. It's equal to negative 9 and then transpose 17 to the other side, that's minus 17. And then combine similar terms. So we have 4n minus 6n is negative 2n equals negative 9 minus 17 is negative 26. And divide the equation by negative 2. So negative 2n divided by negative 2 is n. And negative 26 divided by negative 2 is positive 13. So this is the value of the unknown number. So n is equal to 13. Next is we will have to check the solution. So take note, our equation a while ago is 4n plus 17. is equal to 6n minus 9, where n is equal to 13. So that's 4 times 13 plus 17 is equal to 6 times 13 minus 9. 4 times 13 is 52. Then plus 17 is equal to 6 times 13 is 78 minus 9. 52 plus 17 is equal to 69, and 78 minus 9 is also equal to 69. So that means that we have the correct solution for the equation, where n is equal to 13. That's the value of the unknown number. Next example, find three consecutive integers such that the sum of the second and the third is half the first decreased by 15. Again, find three consecutive integers such that the sum of the second and the third is half the first decreased by 15. Okay, so if we will let x represent the first integer, then the next integer should be x plus 1, because it says here that the three integers should be consecutive integers. So x plus 1 is the second integer, and the third integer is x plus 2. Okay, so x is the first integer, x plus 1 is the second integer, and x plus 2 is the third integer. So we are now ready to write the equation. Okay, it says here that the sum of the second and the third is half the first decreased by 15. So sum of the second and the third integer. So that should be x plus 1 plus x plus 2. So sum of the second and third integer is half the first decreased by 15. So half the first is 1 half x, and decreased by 15 is minus 15. So our equation is x plus 1 plus x plus 2 equals 1 half x minus 15. Step 3, solve the equation. So we have x plus 1 plus x plus 2 is equal to 1 half x minus 15. So here, in the left side of the equation, we can just combine similar terms, where x plus x is 2x, and then 1 plus 2 is 3. And then copy the right side of the equation. We have 1 half of x minus 15. Now, we want to get rid of the fraction. And to get rid of the fraction, you get the least common denominator. So in this case, the least common denominator is 2. So we will multiply both sides of the equation by 2. There. So 2 times 2x plus 3, that should be 4x plus 6. Then is equal to 2 times 1 half of x is 1x, or simply we write x. And then 2 times negative 15 is negative 30. So that's minus 30. So we have 4x plus 6 equals x minus 30. Then we move x to the left side of the equation. So we have 4x minus x equal to negative 30. And then move 6 to the other side. That's minus 6. Then combine similar terms. 4x minus x is 3x. And negative 30 minus 6 is negative 36. Okay, and then divide both sides of the equation by 3, where 3x divided by 3 is x, and negative 36 divided by 3 is negative 12. This is the value of the first integer. How about the second integer? Remember, the second integer is represented by x plus 1. So we will just have to substitute negative 12. So that's negative 12 plus 1 equals negative 11. We have now the second integer. And the third integer is x plus 2. So that's equal to negative 12 plus 2 equals negative 10. So this is the third integer. So therefore, the three consecutive integers are negative 10, negative 11, and negative 12. Okay, let's check our answer. Our equation is x plus 1 plus x plus 2 is equal to 1 half of x minus 15, where x is equal to negative 12. Okay, so we have negative 12 plus 1 plus negative 12 plus 2 equals 1 half times negative 12 minus 15. Negative 12 plus 1 is negative 11 plus negative 12 plus 2 is negative 10 is equal to negative 12 times 1 half is negative 6 and then minus 15. Combine, negative 11 plus negative 10 is negative 21 equals negative 6 minus 15 is also equal to negative 21. So, we have the solution of negative 12 for the equation. Let us now proceed to comparison problems. An electrician needs to cut a 54-meter wire such that one piece is 5 times as long as the other. How long is the shorter piece? So we will let the shorter piece represented by x. So this is the shorter piece of wire. And it says here that one piece is 5 times as long as the other. So that's 5 times the shorter piece. So the longer piece of wire is 5x. Next is to write the equation. When you add the shorter piece of wire and the longer piece that is equal to 54 meters. So our equation is x plus 5x is equal to 54. Okay, let us now solve the problem. So we have x plus 5x equals 54. Combine similar terms. We have 6x equals 54. And divide the equation by 6. 6x divided by 6 is x. And 54 divided by 6 is 9. So this is the length of the shorter piece. So that's 9 meters. That's the length of the shorter piece of wire. Okay, Step 4 is to check the answer. So we have x plus 5x equal to 54, where x is equal to 9. So we have 9 plus 5 times 9 is equal to 54. 9 is, so this is 5 times 9 is 45 equals 54, and 9 plus 45 is 54, which is also equal to 54. So we have the solution of 9 for the equation. Next example. Christine is 4 years younger than Mario. 3 years from now, she will be 2/3 as old as Mario. Find their present ages. So, if we will let x be the age of Mario, then Christine's age will be represented by x minus 4, because it says here that Christine is 4 years younger than Mario. And also, their ages 3 years from now should be plus 3 of their present age. Okay, so from there, we will have our equation. So, it says here that 3 years from now, she will be 2/3 as old as Mario. Christine will be 2/3 as old as Mario. So, Christine's age 3 years from now will be x minus 4 plus 3 is equal to 2/3 as old as Mario. So, that will be 2/3 of x plus 3. So, x plus 3 is the age of Mario 3 years from now. Okay, so let's simplify this. Combine the terms, combine similar terms. We have x minus 4 plus 3, that is x minus 1 is equal to 2/3 times x is 2/3 of x. And then 2/3 times 3 is 2. So, that's positive 2. Okay, so we want to get rid of the fraction. So, we will multiply both sides of the equation by 3, or that's the least common denominator. 3 times x minus 1 is 3x minus 3 is equal to 2/3 x times 3 is 2x, and then 2 times 3 is 6. Okay, next step, we'll move 2x to the left side. So we have 3x minus 2x is equal to 6, and then move negative 3 to the right side. So that's plus 3. 3x minus 2x is x, and 6 plus 3 is 9. So, therefore, Mario's age is 9 years old. While Christine is, okay, Christine is 5 years old, since Christine is 4 years younger than Mario. Right. Okay, so let's check our solution. So here we have our equation of x minus 4 plus 3 is equal to 2/3 of x plus 3. Okay, where x is equal to 9. So we have 9 minus 4 plus 3 is equal to 2/3 of 9 plus 3. 9 minus 4 is 5, plus 3 is equal to 8. And 9 plus 3 here is 12. So we have 2/3 times 12. And 2 times 12 is 24. Divided by 3, that's equal to 8. So we have the correct solution for the equation, which is equal to 9. Let us now proceed to motion problems. Example 1. Two buses leave a station, one traveling north at the rate of 60 kilometers per hour and the other south at the rate of 65 kilometers per hour. How many hours will they be 375 kilometers apart? So what we are solving here is the number of hours when the two buses are 375 kilometers apart. So we will let x represent the time or the number of hours when the two buses are 375 kilometers apart. And also, it is also important in this problem that we have to take note that the formula for distance is equal to rate times time. Okay, so let's consider the bus traveling north. All right. Okay, so the rate of that bus traveling north is 60 kilometers per hour, and the time is unknown, so we will just leave that. We will leave that as x. So meaning the distance traveled by the northbound bus is 60x. Okay, next. For the southbound bus, its rate is 65 kilometers per hour and the time is also unknown, so we will leave that as x. So the distance traveled by the southbound bus is 65x. Okay, step 2. Okay, let me just try to illustrate this. So let's say that this is the station, and then one bus is traveling south at 65 kilometers per hour, or we represented that a while ago as 65x, and the other bus is traveling north at the rate of 60 kilometers per hour. So the distance traveled by the northbound bus plus the distance traveled by the southbound bus should be equal to 375 kilometers. So in how many hours will they be 375 kilometers apart? So our equation is 60 kilometers per hour, or 60x plus 65x equal to 375 kilometers. Okay? So 60x plus 65x is equal to 125x equals 375. And 375 divided by 125, so we divide both sides by 125. Okay, so x is equal to 3 hours. Okay, so in 3 hours, the two buses will be 375 kilometers apart. Okay, so let's try to check our answer. Okay, so bus 1 is traveling at 60 kilometers per hour. So this is, and take note that the distance equal to rate times time. So 60 times 3 is equal to 180 kilometers. That's bus 1. And then the second bus is 65 times 3 is equal to 195 kilometers. When we get the total of this, that is actually 375 kilometers. Okay, so our answer here is 3 hours. Another example, Rudy and Jason are traveling north in separate cars on the same highway. Rudy is traveling at 65 kilometers per hour and Jason at 70 kilometers per hour. Rudy passes the O exit at 2:30 p.m. and Jason passes the same exit at 2:45 p.m. At what time will Jason catch up with Rudy? Okay, so we let x be the amount of time it takes Jason to catch up, while x plus 0.25, that is Rudy's travel time. Why x plus 0.25? Because it says here in the problem that Rudy passes the exit at 2:30 p.m. while Jason passes the same exit at 2:45 p.m. That is a 15-minute interval. And 15 minutes is equivalent to 0.25 hours, or that's 15 divided by 60 is 0.25. Okay. Step 2. Okay, take note that the formula for distance is equal to rate times time. So, let's take a look at Jason's distance. His rate is 70 kilometers per hour, while time is unknown. So it's represented by x. So we can say that the distance traveled by Jason is 70x. So that's rate times time. And for Rudy, the rate is 65 kilometers per hour, while the time is x plus 0.25. So that distance traveled by Rudy is represented by 65 times x plus 0.25. So, in writing the equation, you have to take note that when Jason catches up, he and Rudy will be at the same distance. Take note, they should be at the same distance. So, our equation will be based from that. So, our equation now is 70x is equal to, this is the 70x is the distance traveled by Jason, and Rudy is 65 times x plus 0.25. So that's 70x is equal to 65 times x plus 0.25. That's the equation. Okay, so let us now solve the equation, which is 70x equal to 65 times x plus 0.25. Okay, so we have 70x, and then using the distributive property, so 65 times x plus 0.25 is 65x plus 16.25. Then we move 65x to the other side, so we have 70x equal to 70x minus 65x is equal to 16.25, where 70x minus 65x is 5x equals 16.25. And divide the equation by 5. So 5x divided by 5 is x, which is equal to 3.25. Okay, so since x is equal to 3.25, or that is 3.25 hours, or this is 3 hours and 15 minutes, meaning it will take Jason 3 hours and 15 minutes to catch up with Rudy. Again, it will take Jason 3 hours and 15 minutes, or 3.25 hours to catch up with Rudy. Okay, so let's try to check our answer. Our equation a while ago is 70x is equal to 65x plus 0.25. Okay, we have 70x is equal to 65 times x plus 0.25, where x is equal to 3.25. So this is 70 times 3.25 is equal to 65 times 3.25 plus 0.25. So 70 times 3.25 is 227.5, and we have here 65. 3.25 plus 0.25 is 3.5. Okay, so from here we have 227.5 is equal to 3.5 times 65 is also equal to 227.5. Okay, meaning after 3.25 hours, both Jason and Rudy traveled 227.5 kilometers. Before we end this lesson, let us go back to the learning targets. Assess your understanding if you can. Differentiate between algebraic expressions and equations. Illustrate linear equation in one variable. Solve linear equation in one variable by algebraic methods. And solve problems involving equation in one variable. Enrich your understanding about this lesson through the activities and formative assessments in our module and Google Classroom.